next, right? Yeah, I guess I see some experienced people here as well. Would you guys?
England, Adam.
Oh, okay.
I'm from Turkey, and I'm finishing my PhD from NTU.
Okay, what?
I worked on rendezvous and docking problems. Rendezvous and docking.
Oh, okay. Oh, that's okay. That's pretty cool. So yeah, as he introduced, I'm Akshat. This is Francesco. Or wait, you said Fran, right?
Whatever.
Yeah. Francesco. So we are from Transcelestial, and the one thing that our company is trying to solve is one problem that we're trying to solve is communication. And the one question that we ask ourselves is, what are the civilization's long-term communication needs? So before I start anything, I would just like to show you guys the kind of stuff that we are inspired by. So this is just a short video. Hope you guys like it. There's no audio.
Should be.
There should be audio. Oh, okay.
Material advantages. The sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood. We invest far-off places with a certain romance. The appeal, I suspect, has been meticulously crafted by natural selection as an essential element in our survival. Long summers, mild winters, rich harvests, plentiful game. None of them lasts forever. Your own life, or your band's, or even your species, might be owed to a restless few, drawn by a craving they can hardly articulate or understand, to undiscovered lands and new worlds. Herman Melville in Moby Dick spoke for wanderers in all epochs and meridians. He said, I am tormented with an everlasting itch for things remote. I love to sail forbidden seas. Maybe it's a little early. Maybe the time is not quite yet. But those are the worlds, promising untold opportunities, beckon. Silently, they orbit the sun, waiting.
Doesn't want me to go next. Okay. So I guess you guys kind of understand at our company we're all a bunch of space nerds. We love space, and I think we're in the correct time period where all of these exciting developments in space is happening. So yeah, I consider myself really lucky. So among the different challenges that you have to actually bring ourselves as humans out of the Earth, like of course the major challenges are actually transportation, life support. One major challenge is also communication, like high bandwidth communication that can bridge the gaps of information that you have between planets or between Earth and like another random spaceship that's going in another place. So that's kind of the final goal for our company. For now, what we are tackling is communication on the Earth. And we're doing it using the same technology that we're going to be using later in the future for our space network, which is laser communications, which is, I guess, you guys, why? You want to know more about that. So just to give you like a brief background on what the current state of the art is, we have RF and fiber as the main technologies that you use to connect stuff on the Earth itself. RF is just radio frequencies. You have millimeter wave and microwaves that you use to transmit bandwidth across, like for example, cell towers or on the scale of cities, right? And then you have fiber, for example, the undersea cables, where you transmit data at the scale of continents, like between, for example, Australia and Asia and stuff like that. And for space, it's much worse. Like for example, RF and fiber, they usually have higher bandwidths, like in terms of hundreds of megs. And in the case of fibers, it's like a few terabits. But in terms of space, since it's really far and it's really, how do I say, not static, it's dynamic, it keeps moving, you have to resort to something that's much lower, like few tens of megabits or at max like 1 gigabit. Like for example, the Starlink that SpaceX is doing is like 1 gigabit max per satellite. So what we want to do in the future is press this button. Okay. Yeah. You have fiber optics and you have radio waves. Fiber optics gives you terabits of available bandwidth, and radio waves gives you like the ability to just put something in 2 locations and then just have them communicate wirelessly, right? So an ideal combination would be to have the flexibility of radio waves and ease of installation, and at the same time have the speed and bandwidth of fiber optics. So what we call it is basically what laser communications is. It's called FSO, free space optics, and that kind of tries to solve the problems of fiber and like the lack of ease of installation of fiber and the bandwidth limitations of radio waves. So I'll just give you a brief introduction. So what we do is you have if you guys have ever like opened up have you guys seen a active fiber cable before? So if you see, okay, at some time you might be able to see that there's a little laser that comes out of the fiber cable. So what we essentially do is make that laser go through the air in like a very collimated parallel beam across large distances, and then send it from one side and receive it on the other side. So I think you guys can already imagine that if something is perfectly parallel and it's going over long distances, you're going to have a lot of challenges. So the main part of this presentation is just to let you know what are the major challenges and maybe not give you too much information on how we solve it. So yeah, so in our company, the way we divide these kind of this one major challenge is in three different sections: pointing, acquisition and tracking, optics, and modulation and coding. The first part, pointing and tracking, is just making sure you're looking at the correct direction. So if I'm here in the device, I need to point to that device within like a millidegree, less than a millidegree worth of precision, because we don't want to. We're not doing a few meters of communication. We're doing like a few tens of kilometers of communication. So even 1 millidegree, if you shift left or right, your entire beam is going to be like a few tens of meters away. So you don't want that. And if you want to maintain the same kind of reliability and throughput, you would have to kind of make the beam wide. So if you make the beam wide, then you can't go as far. So there's these kind of trade-offs. So what we want to do is make it as narrow as possible, so it goes as far as possible, because eventually we want to reach space. So that's the pointing acquisition part. The optics part is basically once you are receiving the power, as in once you're receiving the laser on your side, how do you ensure that you perfectly get all of that onto a very small, like for example, if it's a fiber on the other side. I'm not sure if you guys know, but the main core, the center of the fiber is around a few tens of microns thick, and that's it. So you have to concentrate all that light into that single piece of core, and if you don't, then you get no signal. So that's the optical challenge. And the modulation coding part is, I'm not sure if you guys are familiar, if you've taken courses in like the signal processing and whatnot, and if you're familiar with how Wi-Fi works, you have like a channel and then you can modulate the channel in a lot of different ways to